Hi guys, it's Haley, and I had cold PCR with the audience of a scientist. So the way that I would describe cold PCR to a scientist would be that it's primarily used to diagnose certain aspects of cancer. It is based around the idea that the specific allele that they're looking for, or the target sequence that allele is found in, has a lower denaturing temperature than the overall sequence of DNA that the target sequence is in. This type of PCR allows scientists to yield minority alleles instead of just wild type alleles. They're able to find the specific type of minority allele, which is able to give them if that cancer mutation is found in that type of allele, which they can't do with regular PCR. So the two questions that I had from my audience. One was specifically what reagents and or PCR reaction programs would have changed compared to just standard PCR. And the answer is that the denaturing temperature is lowered for cold PCR in order to find the minority alleles. And also that this type of PCR requires ICP assay prior to the PCR products going into the thermocycler. And the second question that I was given was what can cause inconsistent results with this type of PCR? The first being that this type of PCR, the products and the DNA need to be kept at a freezer at the temperatures between -20 and -80 degrees Celsius. And if these products are brought in and out of said freezer multiple times, they will not be able to be read. Also, these type of products, these results are not able to be read automatically right after they come out of the thermocycler. They have to be placed back into the freezer prior to being read. If that's not done, the results will be incorrect. And also the entirety of the PCR products, the buffers and the primers also have to be kept on ice during the entire portion of this experiment. And if they are not, they'll get too warm and they'll denature themselves. So that's all I got for you. And my resource, I used mybioresource.com. Thank you.